That is correct. So the point of the picture is, as elevation or altitude increases, you're going to want to write this down under your picture next to it. Up here, up at the top, let's say this is Mount Everest, okay? This is really low air pressure. Remember, what causes air pressure?
Particles bouncing off each other.
Right, so if there's big spaces between them, they're not going to hit each other as often. But if they're very concentrated, like down here at sea level, you're going to have high air pressure because there's going to be lots of particle collision. So, right now, technically, our air pressure is a little bit lower than at my house.
That's why like our ears pop, right?
Yeah, so if you go up a mountain or if you've ever been in a plane, your ears will pop because the pressure is changing. If you keep going all the way to space, then there's basically no pressure. Okay, so sea level is the highest pressure we can have. Okay, well, some places are below sea level. Okay, that would have the most pressure. Why? Sounds with me? Yeah. Okay. Why? Why is this? Why does this happen? Why does the air get thinner as we go up?
Because it's like the same amount of particles, but it's a greater space, so it has to fill up the space.
Okay, good. But why does it? Why is there more space? That's what someone said yesterday
Affects it, like?
in third period. So what's the relationship between temperature and volume? Yep. If you heat up a gas, it expands, right? That's a hot air balloon. So up here, it's colder than down here. So that doesn't. The temperature doesn't really work. Here's the analogy. Who's it going to be? Shane.
Yeah, Shane.
We're theoretically, we're not going to do it. We're going to lay Shane right on the ground. And then everybody else is going to pile on top of Shane. We're going to stack you guys like firewood, okay? So we're going to have a big stack, and I get to be right on the top. So everybody's, you know, it's kind of weird, but we're all like laying right on top of each other, okay? So all of us. Think we could reach the ceiling?
Yes.
Yeah, probably. What's going to happen before Shane?
He's
He's going to be squashed, right. Okay. So, Alex, what's the analogy? How does that relate to this? Sorry, I put you on the spot. The more what you feel. The more concentrated, the more pressure. Very good. Does anyone know? So that is what's happening here. But what? So think of us as like layers. What layers are on Earth?
Onion layers.
Layers of the atmosphere, right? Likes, please. Hey, good job subscribing. All right, I'm up to like whatever, 30 something.
Ooh, that's all.
I think you're gonna help you out.
That's right. I'll get to 50 before I know it. All right.
Got
Sure, I
gold.
announced that yesterday.
All right. Oh, there it is. Okay. So, yeah, we have layers of the atmosphere. Now, the part that's confusing is we exist in the troposphere, so even the highest mountains, Mount Everest, it's in the same troposphere. So it's not like Mount Everest extends up to the stratosphere. It doesn't. It's not tall enough. But the concept still applies. The closer you get to the top of the troposphere, I always not sure how to say that. The closer you are to the stratosphere, the less pressure you're going to feel. The closer you get to sea level. So again, it's not a perfect analogy, but the weight of the air above it is pushing down on the air below it. So if you were way up here, right near the boundary between the atmosphere and space, called the Kármán line. Well, that's just where we set it. Kármán line. I think that's it. Teach astronomy. I forget all the terms, but there is a certain boundary there. Then you really have hardly any air pressure at all. So, anyways, all you need to know in here, as far as in the class, I think this is cool to know for just real life knowledge, but in here you just need to know as you get closer to sea level, particles become more compact together, condensed together, so it's a lot easier to breathe. Like you can breathe very easily. On top of Mount Everest, can you breathe?
No.
No, you need an oxygen tank, right?
How far from the stratosphere is Mount Everest?
You know what? I don't know the mileage off the top of my head, like how far up the stratosphere is. A few years ago, you guys remember the guy who was in the plane and jumped out?
Yeah.
Yeah, the Red Bull guy. He was right. They were right here. He was right there, right at the edge of the stratosphere.
That's it. It looked like he was in space.
Well, actually, you know what? He might have been up here. He might have. I can't. He was in the stratosphere, but I can't remember if he was at the beginning or the top. I don't remember off the top of my head. Yeah, it looked like
That's
he
a
was in
big
space,
difference.
but there's still a lot. There is a big difference, and I don't remember where he was. Yeah, he wasn't in space yet. So.
Will gases behave most like ideal gases in space, even though it should decrease in temperature?
Are there?
It's a
Like,
good
there's
question.
like infinite.
The problem is it depends on where, because, yeah, space is cold, but it's also really hot if you're facing the sun. So, like a lot of the, so I guess I don't know how to answer that. It's a good question.
Depends on where in space.
If, like, wouldn't gases act like ideal gases because they're trying to fill?
Right, so
space,
they're
so
just
they're just-
expanding, yes.
just-
I would tend to answer that yes. They would try and expand and act more ideal. But yeah, it's because there is an atmosphere or anything between you and the sun, it can get extremely hot if you're in the, you know, can see the sun, but then if you're blocked, so like the bright side of the moon versus the dark side, it's like very different temperature wise. But anyways, yeah, that's all cool stuff to talk about, but we're gonna move on here, just because I want to get to a bunch of stuff today. One more quick question.
Theoretically, if like you had a cylinder with two open ends, and you
So like this, except there's another end. This is open.
and you shove that into the ocean and it hit the bottom, and you suck the water out of the cylinder, would the pressure be at the bottom since it's below sea level? Would it be hard to breathe, or easier to breathe, or would it be like what would like?
Well, I mean, we can't breathe underwater, so what?
No, it wouldn't be in water because you would put.
Like
the-
Oh, okay.
Yeah.
Like New Orleans. It's below sea level.
I mean, you should be able to breathe fine. Yeah, but yeah, underwater. I mean, because it would be so condensed.
Yeah, why does the pressure build up? Because like, don't you have to have like special glass and stuff when you go down to really deep depths?
Yeah, actually, here, let's watch this.
It's because like the water gets like so heavy.
Here, look at this.
Ooh.
Yeah.
That's
So
pretty
so
much what I'm saying.
yeah. So there is. Yeah, it was good question. I want to show you this. You guys ever hear of decompression sickness or the bends?
Oh yeah.
Okay, you can die from it. So
Ooh.
deep sea divers can die from it. This is gonna explain it.
Oh, it's like
it's a
going
good
up too
video.
fast?
The guy explains it well. But yeah, the pressure in different parts of the ocean floor is different depths depending on where, right? But as you get further down towards the ocean floor, yeah, pressure builds. Weight of the water on top, kind of the same analogy with the air, except it's water. So yeah, the pressure at the floor of the ocean is greater than the pressure at the top. I think we all kind of get that. The Marianas Trench, I don't know if I ever say that right. Yeah,
I don't think there's an
Mariana?
S at the end.
Mariana.
Yeah, I don't think there's
Mariana.
an S.
It's Mariana.
Okay, Mariana Trench. What about that?
Deepest place.
Really
Right.
deep.
Yeah,
How
that
deep is it? Like
Deepest
a mile.
depth.
How deep is it?
I forget. But if you could take, something like the size of a cruise ship
It's
and put it in that trench, and it'll be condensed to like a softball.
Ooh.
Like it's so
How
so
do
much
things
pressure.
live there though?
Good question. They adapt. Just kind of like a lot of those fish and animals that we've discovered in the past, let's say 20 years, at really, really deep parts of the ocean with no light, they have like the fluorescent
Anglerfish.
lights and
but
yeah,
how do
stuff
they
like that.
survive the pressure.
Um,
If the pressure's gonna push
right.
that big of a
I don't know, but I don't know if there are any, if there's anything that far
Is
down.
it consciously
So I don't know.
down
Good question.
They're
But
like-
I know
they're
some of
like-
these fish can exist at depths we can't.
That's what you said.
So it's the same thing.
Do
They
you know?
adapt.
Do you know it's like a slug? It's like a type of slug. They can put it in outer space with no like suit or anything.
Water bear.
And it can survive without.
It's
any-
called a water bear. I was just talking to my wife about this. Anyone see? This was not a very good movie. Ant-Man and the Wasp.
I've seen it.
Okay. Do you remember when he goes into the quantum level and there are these weird organisms
Yeah.
swimming around?
yeah.
That's what he's talking about. Those things exist in real life.
Mr. Decker showed us that.
That's
I mean, I've seen the
Yeah,
movie,
like-
but I didn't
like-
think
and
it was.
They're
it's
called water bear. The real name is.
I can't
Just search
remember.
up water.
I know, but I did it the other day and I couldn't remember that I came up with it. Water bear.
Sea bear.
Tardigrade. There they are.
Yeah, yeah.
So But those can
There
live,
they are.
you can put those in outer space.
Yeah, they can live in outer space, they can live in acid,
Oh,
they
yeah, on a
can,
scale,
Don't
yeah,
put those
how
things in
big
outer
are
space.
they?
oh, they're like microscopic. They live in moss and lichen, they're kind of like lichens. They live in mossy areas.
They're doing like experiments to see if we can have immortality for us since they have near immortality.
They're definitely not from this planet, is my opinion. Because
Yeah.
the way that what they can adapt to and live in, nothing else on our planet can.
Wait,
So-
they could be aliens?
They're aliens, yes. Those are aliens, and they live amongst us.
Aliens do exist.
Because Quinch.
Mariana,
If
Mariana,
aliens
Mariana,
exist,
Trench.
then that's what-
Maybe.
that's scary.
But
Alright, listen, this is good stuff, but we gotta move on
They're
here.
upset people don't believe in
I'm just saying that, don't quote me on that.
Confused about that. How could they
Because
survive
because
that actually?
wait, no. This is the thing. A cruise ship is metal.
Right,
A solid can't be compacted.
right,
So
The-
if it's
the-
a solid, how
right.
can it compact into the
but
size
it
of
can
something?
be. So, okay, you take a
Oh,
car,
you told us
I
you
know.
totally-
hold on, take a car,
You're basically lying to us.
and no, not right. And you take that and put it in a trash compactor, or
Okay.
they make it into like a cube, so they can move it, okay? It looks as if it's taking up less space, but the volume of the actual atoms is the same. So, yes, I know what you're saying. You're not taking the atoms of steel and moving them closer together. That's almost impossible. But you can take the shape and change it to something that appears to be smaller.
But
There's literally no way a cruise ship. is
no,
that
but
small.
let's say okay.
Again,
No way.
don't quote me on it, but there's some stat out there that it's something like that. It's
It's
something
just-
really big and it's
Look it
crushed
up.
into the.
Look it up.
I need to get on the class.
Okay.
Well, this is
Now,
part
the
of
thing
class.
This is
Okay.
part of
Okay.
Not what I want to get done by the end
If
of the
you
year.
take a
Because
plate
I don't want to do this whole
of
review.
the bottom of a cruise ship, let's just say a plate.
Yeah, yeah.
It would be thicker than a softball. Let's just say that.
Yeah,
So
How are
if
you
that
gonna-
one plate is
Because
being moved
the-
smaller into
right.
into a softball, how does the rest turn into?
because the pressure is that strong.
But then, isn't that destroying mass?
No, no,
This
no,
is
no, no.
so-
It.
Why can't
It's
you just
becoming
agree
more
with
dense
him?
because it's the same weight.
Agree and move on.
It
I
has-
just do
But solids can't be compacted.
You're right. So you're not moving the atoms any closer.
The
And
atoms
you
are
can
changing.
compact. Okay, if I have a sheet of copper, okay, maybe it's like an inch thick. I can fold that so I can fit it essentially in my hand.
Yes.
I'm still not.
I didn't move the atoms closer together, but the whole sheet, the area of that sheet,
area.
appears to take up less space.
Taylor,
Color
I think
decides
he's
the
exaggerating a
I
little bit
can't
with
color
the.
Ooh,
inside.
good job.
I didn't pass
Yeah, I was
kindergarten,
exaggerating.
okay?
I don't know the stat. but-
This is a plate of metal.
I know what you're saying.
No. I'm not
I
saying
will
the
color
shape.
it
I'm
in.
saying the thickness.
Yeah,
It's
yeah, yeah.
thicker than a softball.
Yes, I understand that.
How
How
does-
can you make this?
How can you make this into that?
if
I
you're not-
understand if it was like thinner than a softball.
no, I
you could
I
crumple that
understand.
into a ball. but-
I'm with you, 100% with you. I don't know the answer, but I do
Then
know
why did you say it?
because
All you
that,
did was make all of us confused, and you.
because that's what happens when the pressure is that great.
I'm great
It
at it.
takes something really big and puts it into a very tiny area. That's what can happen. I just use that as an analogy. I don't remember what the exact stat
Okay.
is.
Killing my brain.
Does that help?
Yeah.
Really. This
You were
entire
taking me too
conversation is
literal,
getting
literal, and I apologize. I don't know exactly. I'll look up what
It's
I
kinda
was
like-
reading.
Hey, you better solve this.
It kind of like you're,
That
you can,
Fretwell?
because if you just press
Yeah.
it together, it's not like combining into it.
Right.
You know what I mean? Like, it's
Right.
not like soldering something.
You're just basically bending it.
It's, yeah,
into a
you're just
different shape.
bending it. So
But
you just
I know what you were getting.
I wanna
You gotta fix
All right.
the situation.
Now, let's, that's not for you guys. We're good with that.
You don't
Alright, now, here we go. So, this is interesting. Here we go.
For the first time, when workers surfaced from their pressurized workspace, the caisson, without step-by-step pressure equalization. The sickness can be caused by several different factors, including the dive time, the depth, and the surfacing method. Decompression sickness can be caused by diving too long or by surfacing too quickly, unless several life-saving rules are observed. With increasing ambient pressure, the nitrogen contained in the air you breathe
Ambient pressure means the pressure around you, the pressure in the air.
dissolves in your blood. In order to keep the nitrogen dissolved when resurfacing, when the ambient pressure decreases, it's vital not to ascend too quickly. This is why it's very important to achieve a controlled ascent of not more than 10 meters per minute. If the pressure decreases too quickly, nitrogen bubbles form in blood and body tissue, as not enough can be breathed out.
Okay, so basically nitrogen gets dissolved in your blood because the pressure is great enough to condense that nitrogen gas, because gases don't dissolve in liquids very easily. But if you put them under a lot of pressure, they can. CO2 in soda is a great example. It's under a lot of pressure. If you have a 2-liter bottle, 20 ounce, whatever, you squeeze it, it's tight. That's because there's a lot of pressure keeping the CO2 in the soda. As soon as you open it up, what happens? And you see the bubbles. That's exactly what happens if you dive in the ocean. What happens is the nitrogen in your body dissolves into your blood, which is not that big a deal as long as you come up slowly, so it slowly can get back to normal. If you go quickly, it bubbles like in a soda bottle, and you don't want bubbling in your blood. That's a bad, you can die from that, things can burst. Alright? So that's a big deal. That's a huge thing. Decompression sickness, also called the bends. And it's just simple pressure gas law. That's what it is. So you have to go very slowly, and they showed the guys working in this tunnel have to climb slowly as well. It's not just if you're in the water, it's if you're kind of your concept there. Alright? So I just wanted to bring that up to you again. That's the gas law at work there. Alright. Now, before I show you how to do your homework, take out your reference tables. Let me show you the equation, and then we're going to blow up some balloons.
Yeah, some still have balloons.
Did you ever show Alex that,
No, not yet. It's still set up. It's still out, so I
It's
will.
like, are we all blowing up balloons?
You're going to have partners.
Alright.
So Alex, in lab tomorrow, try and remind me to show
I'm
you.
blowing it. I'm
Okay.
blowing it. Come on, Rebecca.
Write in your notes, combined gas law. Combined gas law. This equation is on the back of your reference tables. I want you to find it. This is what you're going to use on your homework. We're going to watch a mole day video because it's funny and it's mole day. I'll explain that. We're going to blow up some balloons because it's mole day. And then we're going to watch one more video on the gas laws, and then we're going to do a sample problem. Okay, we should have time to do all that, hopefully. Well, we need to, because otherwise you'll have no idea how to do the homework. All right, so today's mole day. Does anyone know why? You ever learn what a mole is?
Is that the word rodent?
Well, okay, yeah. So if you guys look over there, there's pictures of moles. If you draw a picture of a mole and you give it to me by Friday, I will give you up to 2 points on that test you just took.
Oh, word.
If it's kind of just like
so
you did it very quickly and it's just like okay, I'll give you 1 point.
Just like,
Yeah.
what's a good drawing?
Those are pretty good. Like the ones that are colored are like, the thing is like if you don't color it but it's well done, I'm gonna give you 2 points. If you color it, I'm still only giving you 2 points. So it's really up to you what you want to do. 2's the max. So if you make it look like the best mole I've ever seen, you're still only getting 2 points. So it's up to you. It's just kind of for fun. If you want to do it, you get the 2 points, or 1 point if it's kind of like I'm a terrible artist, so I'd probably only get 1 point if I was gonna draw it.
Same.
So it's whatever. It's 3 points, right? So whatever you got, you don't have to do it. It's just for fun. We'll hang them up.
Print a picture.
All right. Anyways, yeah, those are the rodents. That's not what a mole is in chemistry. Here is a mole in chemistry. You do not need to write it down. 6.022 times 10 to the 23rd. That number is a mole of anything. So a mole is an amount. So if I had a mole of Tyler, you would have that many Tylers. It's a lot of Tylers. Okay?
Yes.
If I had a mole of markers, I would have this
Oh
many
my god.
markers.
It's a unit of measurement?
It's
I
a
would
unit of
use my
measurement.
mind.
If I had a mole of money,
Oh.
or dollars, let's say dollars, I would have that many dollar bills. Okay, so I'd be pretty rich.
Just a dollar?
Okay? What?
What is a dollar?
Well, that's a lot of dollars.
Just $1, that's like,
That's a
About
6 with
$10.
23 zeros. That's more money than like 10
More money than
generations
I
ago.
have.
Yeah, more money than I have. So, anyways, that number was figured out by this guy named Avogadro, and they make some avocado analogies for that, which is kind of funny. So you'll watch the video. Why is today Mole Day? 10/23. Okay, 10/23. Kids always want to know why isn't it June 2nd? I don't know. I I didn't make it up. Chemistry people said today's mold day, so 1023 is mold day.
It's also national crop.
So you don't need to know that number, but I need to bring it up and teach it to learn what a mole is. We're not using moles yet. We will in calculations. Okay? And where it's really relevant is if I want to go in the back and measure 1 mole of salt, I can't do that on a scale. What's the scale tell me? Grams. So you guys need to know what moles mean and how to use the masses from the chart to do something like that. All right? So that's why it's relevant. And then we're going to blow up some balloons, and that'll help you understand a little bit too. So here's your mold day video. It's kind of silly. Some of the stuff is kind of old. It's an older video, but it's funny.
Do we have to remember that?
No.
Alright.
Happy Mold Day to you. Happy Mold Day to you. Happy Mold Day, dear students. Happy Mold Day to you. How many atoms are you? Cha-cha-cha. That's 6.02. Cha-cha-cha. Times 10 to the 23rd.
Wait.
But
There's a picture in here. I just can't look at it anymore, so I'm going to skip it.
Why?
Why don't you?
Curious now.
Hydrogen.
Oh, I'm
so you're
freezing.
gonna unfreeze
Oh!
Water found in
Sorry.
water.
Why?
One
What
number
picture is it?
is 2. What is mold? 2 moles.
I don't know mine.
A coefficient ratio between every 2 formulas in a balanced equation. What is molar mass for a formula? At an atom's atomic masses in grams per 1 mole.
Okay, that's something you do need to know down the road. If I wanted a mole of salt, what I would do is I would go in the back and I'd mass out a certain amount. How do I know? The chart tells me. What is the mass of sodium over there? 23 grams. What's the mass of Cl?
35.
35 grams.
35.
If I add those together, what does that equal? So that unit, grams per mole here, is how we figure out, okay, I'm gonna go in the back, take my thing of salt, and I'm gonna mass out 58 grams. If I was to hold 58 grams of salt, I'd be holding 1 mole of salt, which means I'm holding that many salt particles. So that's what a mole is, and that's how the mass helps us understand it, and that's why I'm talking about it. Plus, it's mold day. But again, you don't need to know this now. I'm bringing it up because it is mold day, and you might as well celebrate.
How much gas in 1 mole? That's 22.4. 22.4 liters. Happy Mold Day to you. Happy Mold Day to you.
You guys all know who Yoda is, right?
Yeah.
Who?
Yeah.
No, I'm just kidding. I'm kidding.
Okay. All right. So that's kind of a silly video. Now I need you to pair up. You come up and grab 1 string and 1 balloon.
You got the balloon, I'll grab the string.
Who wants to go first? Renee, I'll
And Quinn, hit the lights, please, will you?
I'll blow the balloon.